Now let's do an application problem. In this question, it states Mary is walking to school with Robert. The direction in which Mary is walking is defined by the equation x plus y minus z equals 6. Meanwhile, Robert points a laser where Mary is looking at the equation expressed by this. Determine the point in which Robert points his laser with respect to Mary. So first thing we will do is separate put this equation in parametric equation. So we're gonna have x equals 8 plus 3t. We're going to have y equals -1 because t is 0 at the y component, and z equals 4 minus t. Now we have our parametric equation, and what we'll do now is substitute these values into this equation. So I'll just bring this down here, or actually I'll write this here. So if when we have x, or I'll write the equation first on top. 6, so x would sub in for that, y would sub in for this, and z would sub in there. So we'll get 8 plus 3t minus 1 minus bracket 4 minus t, 6. Now, when you expand this, you'll get something that looks like 4t equals 3. So therefore t equals 3 over 4. So now we know the t value. What we will do now is substitute the t value into this parametric equation to determine the point in which Robert is pointing the laser at Mary. So for our x component, we'll have 8 plus 3 over 4, which will give you 41 over 4. We have y equals -1. There's no t value, so it'll just be -1. And finally, z equals 4 minus 3 over 4, which will give you 13 over 4. So therefore, the point you get is p 41 over 4, -1, comma 13 over 4. So this point is the point where Robert's laser intersects with this plane, you could call it, which is the direction in which Mary is looking.